Another definition in the fluid kinematics, the streamlines. Streamline is a line that's tangent to the velocity field at each point in the flow domain. For example, if you return to this slide, let's turn on this. At this instant of time, if I draw a line that is tangent to the velocity vectors at each point in the domain, so this line is called a streamline. For example, in this flow domain, if I draw a line connecting the velocity vectors and tangent to the velocity vector at each point in the domain. For example, the streamline at this point, if you draw it like this, it's tangent to the velocity vector at this point. This is what we mean by the streamline. Streamline is a line that's tangent to the velocity vector at each point in the domain. So you could imagine how all the streamlines will look like in this flow domain. I will have a bunch of lines originating from the origin, getting out from the origin, and look like this. This is a streamline. Streamline is a line that's tangent to the flow domain, to the flow at every point in the flow field. Okay. Since the streamlines are tangent to the velocity vector at every point in the flow field, there can be no flow across a streamline. What does this mean? At each point, you have the streamline tangent to the velocity vector. So there are no velocity vectors perpendicular to the streamline, which means that no flow could cross over the streamline. The flow could happen only between the streamlines. No flow could cross over the streamline. This is what is meant by this sentence, that there is no flow across a streamline. Since the streamline is tangent to the velocity vector at each point in the flow domain, this means that for example, in a 2D flow, in a 2D flow, if you have two velocity components, u and v, from the definition of the streamline, the slope of the streamline will be the same slope of the velocity vector. At this point, for example, the slope of the streamline is a tangent to the streamline, and the tangent to the streamline is inclined with an angle that is equal to the angle of inclination of that velocity vector. So the slope of the streamline is the same as the slope of the velocity vector. The velocity vector, if it has components u and v, so the slope of the streamline dy by dx will be v by u. This thing and these relations should have been explained in detail in the lecture. I'm just doing a quick summary. Okay, path line. Path line is another way to visualize the flow. What do we mean by a path line? The path line is the path or trajectory traced out by a moving fluid particle. What does this mean? For example, suppose I have a fluid particle that we start to observe at this point and at this time. After a certain time, we found that the fluid particle was here, and after another time, the fluid particle went there, and so on. So if we track the path of the fluid particle as it moves in the flow domain and connect all the dots together, we will have the path line. So the path line is a path or trajectory that is connecting all the points upon which the fluid particle starting from a certain point has passed. So if you have the velocity components of the fluid particles, for example, in a 2D flow, you have U and V. If you want to find the path line, you integrate this equation. The velocity of the fluid particle is dx by dt. This is the velocity in the x direction, and the velocity in the y direction is dy by dt. You separate the variables and integrate, you will get the position in terms of x and y for the particle at any time t, given that that particle has started from a certain position. Of course, these equations will be explained in detail, and we will apply on it in the problems. The third thing is a streak line. The streak line is a different way to visualize the flow. We have the streamline, a line that is tangent to the velocity vectors at each point in the flow domain. We have the path line. You pick a fluid particle and you track this particle as it moves in the flow domain. The streak line is different from streamline and path line. Okay, say we focus on this point in the flow domain, and at time t node, a fluid particle passed through this point, and it moved in the domain. It took a certain path line, and after a certain time, at time, let's say t1, another fluid particle gets out from this point and took another path line, and a third particle, and a fourth particle. All these particles, each one of them has taken a different path line, but they all share that they started from the same location. Okay, here is the thing. The streak line is that you say, after a certain time, for example, at time t equal whatever, I want to draw a line that connect the locations of all the particles that have passed through this point. So the line connecting the locations of the fluid particles that started from this point is called a streak line. So you can see that this is the path line of this particle. This is the path line of this particle. This is the path line of this particle. After a certain time, each particle can be found in a certain location in the flow domain. It's not necessary that they will be at the same location. Each one has taken its own path because this particle, although they have started from this point, but maybe this particle has started from here with a velocity component in the x direction and the velocity component in the y direction different from what this particle has started with and different from what this particle has started with. So each one has started with a different velocity vector, which means that each one will take a different path in the flow domain. What I'm interested in is at certain time, what will the line connecting all these particles look like? This is what we mean by a streak line. The three lines, streamline, path line, and streak lines, are three different methods to visualize the flow in fluid kinematics and fluid mechanics in general.